17 tells us to let f be a function that's even. So even means that it's symmetric about the y-axis. So it's the same on both sides of the y-axis. That's why it only gives us the positive values. We can kind of figure everything out from the right side of the graph and then flip it over the y-axis to find the other side. So it gives us all the table of information, kind of like our homework the other day, except that just gave us a big clump of information. Here it's ordered in a table. So for this first part, this tells us f of x tells us the points on the graph. So over here, start the graph going from -3 to +3. So it says when x is 0, f of x is 1. So we have a point at 0, 1. When x is 1, we have a point at 0. When x is 2, we have a y value of -1. So that's the start of our graph. Now, the second, or the first derivative here, the second line down there, tells us when it's undefined, negative, 0. So we can use all of that information to make a number line for the first derivative. And we're going to go from 0 to 3. We don't have to go to the left of 0 or to the right of 3, just everything in between. So when x is 0, the derivative is undefined. Between 0 and 1, it's negative. At 1, the derivative is 0. Between 1 and 2, it's negative. When x is 2, it's undefined. And then from 2 to 3, it's positive. So we need to look at this and see what it tells us. It tells us this graph is decreasing until we get to 0. And until we get to 1, and the derivative is 0, then it decreases more. Then it increases from 2 to 3. So it changes from decreasing to increasing at x equals 2. That's going to be a local minimum. Now, second derivative, we can use this information to set up a number line for the second derivative, using the same values. And the second derivative is undefined at 0, positive from 0 to 1, 0 and 1, negative, undefined, and then negative. So at x equals 1, we have an inflection point. It changes from positive to negative. We already have these points. Now we can use these number lines to help us with the graph. We start off from 0 to 1, decreasing, going down, which would make sense because we have to start here and get to this point, so it has to go down, and it's concave up. So the graph has to open up. Then it continues to decrease to get down to this point. It makes sense. And the important part from the number line is that it's concave down, so it turns. That's an inflection point. It changes from concave up to concave down. Then from 2 to 3, it's concave down again. So where you end it doesn't matter. It ends below the axis, at the axis, above the axis, so long as it's concave up. Now that's the first part of the graph. We said it's even, so it's symmetric with the symmetric about the y-axis, so we can just copy the same thing on the other side of the graph. Now we have the graph from -3 to 3. Part A, I like to do the graph first before I answer all these questions. Part A, find the x-coordinates of each point, which f obtains an absolute maximum. So absolute maximum. Right here at x equals 0, we have an absolute maximum. Or an absolute minimum value. So right here at x equals 2, x equals -2, we have absolute minimum values. Part B, find the x-coordinate of each point of inflection point, or each point of inflection on the graph of f. Justify your answer. So where do we have an inflection points? We have inflection points. There are inflection points at x equals 1 and x equals negative 1 because, important to explain when it asks you to, because the concavity changes at those values. So you can say concavity, you can say its second derivative changes at those values from positive to negative or negative to positive. And then part C, sketch it. We've already done that.